Today's day 2 of graphing rational functions, and we'll be looking at ones that have multiple sections besides not just two dividers, but they have multiple ones, as well as slant asymptotes. So let's go ahead and look at this first one. This first one, we have in the numerator, we have a -2 that can be factored out of all of them, and it looks like we're going to need to use the box to factor. In the denominator, it looks like we need the box to factor as well. So let's go ahead and factor those two things. First off, I'm going to go ahead and factor it what it would look like if I took and removed the -2 from all the places in the numerator. And that would give us x squared plus 5x minus 4. Excuse me. Let me reverse that real quick. I factored out it is factoring out a -2, so that's going to mean x squared minus 5x plus 4. And my denominator is going to be, I can factor that, or I can just leave it unfactored just right now. It's up to you whichever way you want to go if you want to do both pieces. And I'm going to go ahead and show you the box I'm factoring, starting with my numerator. So I have x squared and a positive 4. And so what multiplies give me a 4x squared? That when I add it gives me a -5x. Well, that would be -4x and -1x. And when I look to see what can come out of that first row, and x can come out of the first row, out of the second row, a -4, first column an x, second column a -1. And so this is going to factor to x minus 4 times x minus 1. And so now I'm going to factor the denominator same way using the box. And so when I factor this, the x squared goes here, the -9 goes here. And so I'm looking to see what multiplies to give me 9x squared that will add to give me a 0x. So -3x and positive 3x. So -3x, x, positive 3. And so that denominator is going to factor into x plus 3 times x minus 3. And I'm going to go ahead and rewrite that here in a second. I just knew I needed the space underneath. So let's go ahead and rewrite this. So f of x is equal to -2 times x minus 4 times x minus 1, all divided by x plus 3 times x minus 3. And if you look here, nothing can cancel out, so there are no holes. And then I need to take and find each of the other two pieces. So I need to find all the other pieces. So my vertical asymptotes come from setting my denominator equal to 0. So my denominator was x plus 3, x minus 3. And so for that to be 0, one of those two products needs to be 0. So either x plus 3 needs to equal 0, or x minus 3 needs to equal 0. So x is either equal to -3 or positive 3. So my vertical asymptotes are at those two locations. And so I can come over here and graph my vertical asymptote. Oops, just a second. So we are looking next, we're going to try to find the y-intercept. And so when we find the y-intercept, it really doesn't matter if you plug into the original or the factored, it's your choice. Some like to plug it into the original because there's a lot you can cancel out just right away. Some like to plug it in here. I'm going to show you how it would look if you plugged it into the original. So f of 0 is you're plugging in 0 for all the x's. It gives you -2 times 0 squared sorry, my handwriting there, plus 10 times 0 minus 8, all divided by 0 squared minus 9. And so that's gone. When you multiply anything by 0, it's gone. And so we have negative 8 divided by negative 9. Which reduces to 8/9. And so our y-intercept is 0 m per x, comma, 8/9. Our x-intercept is a little bit more challenging to look and locate. You have to set your numerator equal to 0. And so we are going to have the numerator, which is negative 2, x minus 4, x. Wait a minute, that should not be minus. No, it is, okay. X minus 4, x minus 1. And we're going to set that equal to 0. And so that means one of those three factors have to be 0. So negative 2 equals 0. That never can happen. X minus 4 equals 0. Well, that's going to be 0 when x is equal to positive 4. When I add 4 to both sides, x becomes positive 4. X minus 1 is going to be 0 when x is equal to positive 1. So my two x-intercepts I have are 4, 0 and 1, 0. So I'm going to go ahead and plot those key features on my graph. So at 0, 8/10, or excuse me, 8/9, which is going to be really close to that 1. 4, 0, 1, 0. And the other thing I can plot on my graph is I can go ahead and plot my vertical asymptotes and horizontal asymptote. Oh, we haven't found my horizontal asymptote yet. Let's go ahead and plot the vertical asymptotes. So vertical asymptote is at negative 3. It's going to be at positive 3 as well. And then let's find our horizontal asymptote. So the horizontal asymptote is, you look at the original problem, and my highest power is squared, and it matches in the numerator and denominator. So that means my horizontal asymptote is the reduced coefficient. So it's that negative 2 divided by 1, because there's an understood 1 here. So y equals negative 2 is my horizontal asymptote. And so I'm going to go ahead and graph that. Which, when we graph this, we see why there's as many x-intercepts, is this is no longer the asymptote. So we have it down here that we're going to be shifting everything down a little bit. And so let's go ahead and find those key features. We're going to look at them on the graph, or look at how the signs are going to be. So just draw a line here for separating my totals. So let's find our key features. So these are all my components that come into play for determining my sign. And so negative 2, x minus 4, x minus 1. Oops, I did not give myself enough space. X plus 3, x minus 3, and this is our f of x. So we need to figure out what places are dividing sections, what are separating out my number line. And those 4 places are dividing it. So I am going to figure out, think of this as a number line. So at x equals -3, actually I'm going to do that real quick so I can get those zeros off. X equals -3. X equals, the next one we have is at +1. X equals, the next one we have is at +3. And then x, the last we have is x equals +4. So I need to find something. These are our dividers at each of these locations. And so what number is smaller than -3? Well, I'm going to use the number of -4. A number between -3 and 1. I'm going to choose a number of 0. Between 1 and 3, I'm going to choose 2. These are right next to each other, so it's going to be a little bit challenging. You can think of it as 3.5 or 3.5, and then choose a number bigger than 4. And so as long as it's something in between, and it's going to help us determine signs as we go throughout this. So if I plug in a -4, well, this top row is never going to change. It's going to be negative for everybody because there's no way to plug anything negative or anything into a -2. Now let's look at the next bit. -4. -4 minus 4 is going to give me a negative. -4 minus 1, still a negative. -4 plus 3 is going to be a -1, so that's still negative. -4 minus 3, still negative. And so I need to count 1, 2, 3, 4, 5. If I multiplied 5 negatives together, I would end up with a total result of negative. So that means that on the left of this vertical asymptote at x equals -3, I'm only negative. So that means my graph would be restricted to look like this on the left. Now the middle section, we really haven't worked with the middle section before. We haven't seen how the middle sections behave. So let's talk about that real quick. That middle section has 3 behaviors it can be. It can either be up, it can be a parabola looking thing that goes down, and this middle section could be all sorts of stuff. So it could be a straight parabola, it could have some curves in there. I'm not really, for the purposes of Algebra 2, I want you to have the basic shape. There's a whole lot that can be going on in this middle section, and I'm not going to expect you to have all those details. The other thing you could be doing, and this is typically when you have an x-intercept in this section, if you have just one x-intercept, it typically is a graph that looks like one of these two, where the two ends are going to opposite directions. One's going to positive infinity, one's going to negative infinity. So just keep that in mind. So we're looking at this middle section. Since we have this x-intercept, that leads me to believe that it's going to be like one of these two, because there's only one x-intercept. There are ways this can happen without, but typically that means it's going to be that little snake-looking one. And so this middle section we're going to find, and so we're going to go ahead and start with the left-hand side of that middle section, everything that's smaller than x equals 1. So we're going to choose a number smaller than 1. I chose 0. You could have chosen any number between -3 and 1. So if I plug a 0 in, 0 minus 4 is negative. 0 minus 1, negative. 0 plus 3, positive. 0 minus 3, negative. So now I have 1, 2, 3, 4 negatives. 4 negatives means this whole section is positive. So that means everything that goes from this border wall to this intersection has to be positive. And so remember, on those asymptotes, I'm running along it like I'm running up towards a fence, like someone's playing defense against me and trying to push me out of bounds. Oops. See if I can sketch it down. Now, let's look at between 1 and 3. So this little piece that goes between that 1 and this 3 asymptote. What am I going to do? Am I going to go back up or am I going to go down? So let's find out. If I plug in 2, 2 minus 4 is negative. 2 minus 1 is positive. 2 plus 3 is positive. 2 minus 3 is negative. So let me count my signs. 1, 2, 3 negatives. 3 negatives multiplied together is still a negative. And so that means this is going to go on farther down. So on this next section, we're trying to see, did I somehow come from the bottom and try to go up? Or did I come from the top and try to come down? So I chose 3.5. It just needs to be a number between the positive 3 and the positive 4. And this is where I told y'all think about this just with signs is beneficial. So 3.5 minus 4. 4 is bigger, so that means this is negative. 3.5 minus 1. 3.5 is bigger, so that means this is positive. 3.5 plus 3, positive. 3.5 minus 3, that's going to be a positive 1/2. So I have 2 negatives, that means this section is positive. Now let's do the last section. I just chose any number bigger than 4. So 5 minus 4, positive. 5 minus 1, positive. 5 plus 3, positive. 5 minus 3, positive. So I only had one sign in that section that was negative. So that means the whole thing is negative in that section. And remember, I'm going to behave where I go close to that asymptote. And so here's one that has a horizontal asymptote that's not at the x-axis and kind of how it behaves, and plus it's going to have that has a middle section. So let's look at one with a slant asymptote. And so starting off things the same, we're going to still factor out what can factor, and so that gives me f of x equals, in that numerator I can factor out an x, giving me x squared minus 2x minus 8. And in my denominator, I have a negative 4 I can factor out, giving me x squared minus, I can factor out more than that. I can factor out 4x, giving me x minus 3 when I factor it. Now this numerator I can factor more. You would use a box to help you factor it. For time purposes, I'm not going to show you that step. But if you need me to in class, ask. And the 2 parentheses that I'm going to create, but 2 things can multiply to give me negative 8x squared. That would give me that negative 2 is going to help me create it. And that's going to be the negative 4 and positive 2. Negative 4x times x minus 3. And then I'm looking to see what can cancel. And so I have a hole. When x is 0, there's going to be a hole for the y value. And so my hole is going to be when x equals 0. Now, to figure out where I actually need to graph it on the graph, I need to plug in the 0 into this reduced function. So let me go ahead and rewrite that with everything canceled out that can cancel. So f of x equals x minus 4, x plus 2 over negative 4, x minus 3. Now, when I'm working this, I've got that reduced, and so I had that whole was when x was equal to 0. So I need to plug a 0 into the reduced 1. And so f of 0 equals, and 0 minus 4 times 0 plus 2 divided by negative 4 times 0 minus 3. And so I have negative 4 times positive 2 divided by negative 4 times negative 3. And that's going to reduce to negative 2/3. And so my y value is at negative 2/3. That means I have a hole at my y-intercept. So there is no y-intercept. This is one of the weird ones that's going to have a no y-intercept. That is very rare, but it can happen. Now, let's find our x-intercept. So to find your x-intercept, that means I'm going to replace everything in my function that's, oops. So it's going to be f of 0. And I'm going to go ahead and show you this one on the, oh, excuse me. I just went blank. I was about to show you the y-intercept. It's when our numerator is equal to 0. And again, it's your reduced numerator. So x minus 4 times x plus 2 equals 0. And so that's going to be when x is minus 4 is equal to 0, or x plus 2 is equal to 0. So my two x-intercepts are at positive 4, and x equals negative 2. And so it's going to be 4, 0, and negative 2, 0. My vertical asymptote, or are the ones where my denominator is equal to 0. And so I'm going to set negative 4 times x minus 3 equal to 0. So negative 4 equals 0. That can never happen. X minus 3 equals 0. That's going to happen when x is equal to 3. So I have one vertical asymptote, and that's going to be at 3. Now comes the trickier part. We need to find our slant asymptote. And so let's look at finding our slant asymptote. And so when we're trying to find our slant asymptote, that's when we use that box and we have to divide. And so when we're dividing, again, go back to your original equation, 4x squared, 12x, 0 plus 0. We need to get to where it's at x cubed. Well, this is a 1. So 1 divided by negative 4 gives me a negative 1/4. X cubed divided by x gives me an x. So negative 1/4 times 12 gives me a negative 3x squared, is x times x. And then the last one is going to be 0x. So I need to think about what 3x squared plus what is going to give me that negative 2x squared. And that would be a positive 1x squared. To go up, I divide. So 1 divided by negative 4 is a negative 1/4. And x squared divided by x means my variable is gone. Now, I'll multiply down. That gives me a negative 3 and a 0. But really, these two places don't really matter. For our purposes today in finding your slant asymptote, it is just going to be what is before the remainder. Okay, so on this, I know my slope is 1/4. My y-intercept is negative 1/4. So that's going to be a really hard one for me to actually graph. So I need to think about what value, oops, that's supposed to be a -1/4. What value I can plug in for x that would get this to where this is going to be like a whole value. And if I plug in a positive, so if I think about it as the values, and this is something where you can do a table, or if you wanted to go into your graphing calculator and type in that equation and find a table of values, if you don't want to spend the time trying to figure it out. But at +3 for x, it's going to be what I need to complete this fraction. So that's going to be -1/4 times 3 is going to be -3/4 minus 1/4. And so the y value there is going to be at -4/4, which is -1. And so I'm going to come down to start off at 3, -1. That's where that asymptote's going through. And my slope is drop 1, right 4. Rise 1, left 4. And then I just keep plotting along that line. And so I'm going to go ahead and graph that. And so that's my slant asymptote. And so to graph your slant asymptote, you actually have to go back to graphing a linear equation and those features. And if you need to, you can use your graphing calculator to help you find it. And I did not go over my domain on this one yet, so my domain is all reals, except x equals, it's made of 2 x-intercepts, so -2, and my vertical asymptote, 3 and 4. And these are the places that I'm really dividing my number line with, if you've noticed down here at the bottom. So let's go ahead, and we found all the pieces for our chart. Let's go ahead and use our chart. 1, 2, 3, 4. Excuse me, 1, 2, 3, 4. Okay, so this one's good. And so again, that's the bottom line. It's going to be the total area. So I need to break out my pieces, and again, I use the reduced. So x minus 4, x plus 2, -4, x minus 3. And then I split it apart into the pieces that are going to fit. So x equals -2, x equals +3, and x equals 4. So I need to choose a number that's smaller than -2. -3 works. If I plug a -3 in, it comes out negative. -3 plus 2 is negative. -4, well, that's going to be negative all the way across. There's no number I can plug in. -3 minus 3 is negative. I have 4 negatives, so that makes that section positive. So from -2 going towards the left, that entire section is positive. So I'm basing and just kind of going along that asymptote. Now from -2 to +3, choose a value. I'm going to choose 0. Oops, we're in the wrong spot. So I plug 0 in. 0 minus 4 is negative. 0 plus 2, positive. We've already checked out the -4. 0 minus 3, negative. So I have 3 negatives. That means this section is negative. So going from here, make sure to go through that hole and follow that asymptote. Now let's look at the next section. So we're looking between these two spots. Am I coming from down below, or am I coming from the top? And so I plug in a value between 3 and 4, so I'm going to do 3.5 again. 3.5 minus 4, well, that's negative. 3.5 plus 2, positive. 3.5 minus 3 is positive. So I have 2 negatives, making that section positive. Let's go to the next one. Choose a number bigger than 4. 5. 5 minus 4, positive. 5 plus 2, positive. 5 minus 3, positive. So in this section, I have 1 negative. So that means from here on, I am negative, and remember that we are going along this asymptote, so we're not going to go below it. And that's graphing that slant asymptote.